Alright, in this video I'm going to demonstrate the use of the slider for the purpose of exploring inverse functions. So I'm going to also show you a couple of other tools. One of them is the reflect about a line tool, which is also very important to know. So let's begin with inputting the parent function f of x is equal to 2 raised to the x. And there you go, there's your exponential function. And I'm then going to go to slider, and I'm going to click on slider. And once you click on slider, click again on the screen, and you can now adjust the width or the x values which you would allow your graph to take on. So I'm going to go from -10 on the x-axis all the way to +10 on the x-axis. That's my choice because of what I can see here. You can make this any number, smaller or larger as you wish. And I'm also going to go by increments of 1 and hit OK. So there's my slider. Right now it has no function. All it is, it's the values -10 to 10, +10. I'm going to stop at a 0 to start. Notice I begin with a parentheses, and I'm going to put in a coordinate pair a, comma, f of a. And if you notice, what appears is that typical y-intercept that is one of the characteristics of the exponential function. One element that I'm going to change here right off the bat, before I even begin demonstrating this, is I want to change the actual display. I don't want it to say A, because as I move it across, A is not going to serve me a purpose. What I want to know is what is a coordinate. So if you notice, I clicked on it and I go to settings. You can right click on it with your mouse, go to settings, and then you see this show label. I want to change that from A to what is the value of A, because that is what I'm teaching. I'm teaching the coordinate pairs of inverse functions and what's happening between them, what is unique to them. Okay, now I would like a slant asymptote because that's going to help me use the next tool. The next tool is your reflect about a line tool, which we're going to use. So I know that this slant asymptote is y equals x. I don't know what I just typed there. Let me change that real quick. There's my slant asymptote. And I need this. I need the slant asymptote to use this function, the reflect about a line. So the first thing I'm going to do is I'm going to right click again on that exponential function. I'm going to go to reflect about a line, and I'm going to go ahead and click on the exponential function. I'm going to click on my asymptote, and notice that I get the logarithmic function, which is its inverse right away without much effort. I also want to do the same thing with this point. So I'm going to click on the point, make sure that that little box is highlighted. I want it to reflect about a line. So I'm going to click on the point and then click on the slant asymptote again, and it should be giving me this point over here. So let's go reflect about a line, and there you are. Notice that it also took the value, it copied in a sense the setting, where this setting will be 1, 0 as well. So the coordinate points, if you notice 0, 1, if I took the function y equals 2 to the x and I set x to 0, you get 2 to the 0, which is 1. Its inverse function, which is a logarithmic function, has coordinate points 1, 0, and so on. So if I increase this one increment, let's go to 1. So 2 to the 1 is 2, and therefore the logarithmic function is 2, 1 as a coordinate pair, right? And so on and so on. And so this would be a great way for students to explore the relationship of the coordinate of the inverse function and they can do so as many units as they wish to go out to, so you can play along with it. You notice you don't even get to see it once A goes past 3, because we know that and over here, by the way, if I lowered this just a bit, you could see it. All right, so this is a really great little tutorial. I hope you enjoy.